Okay, the standard error of the mean right here is that standard deviation over the square root of n. And I came down here and I was doing the 90% and the 95, and I was going to just leave it, and it turns out I can't. Your 95% is actually, when I use the 2, it's actually that 95.5%. This 99% with the 3 is actually the 99.7%. If you were using the roughly, you actually would end up using this chart right here. As you can see how for the 90%, I have 1.645 times that 141. Okay, and this is where we get it. That is 90 right there. Is 90%. If you move it over 2, that'll give you 90%, 1.65. The 95% is actually this 1.96. And the 99% is this 2.58. So for multiplying stuff, we might as well multiply by the actual one. Like I said, I was going with the roughly that this other book had been doing. And I was trying really hard to keep it roughly, and I just couldn't do it in the end. The thing doesn't change, though, that you're adding together. It is still the mean plus whatever that t is that we've got here times your standard error of the mean. Okay? So it really didn't change what we were doing. It just changed what I was. It just changed your multiplier. Okay, instead of doing the roughly, which is the 95.5% you see here, and the 99.7% for 3, we were doing the exact for your 90% confidence level, your 95% confidence level, and your 99% confidence level. But the formula stays the same. Okay, once again, they were doing the roughly part. And this is where you see I couldn't do it at the end. Your multiplier, and remember, use the chart. That'll be the quickest. Okay? Alright. So, find the standard error of the mean for the normally distributed sample. Then find the intervals about the mean that have a 90% level of confidence, a 95% level of confidence, and a 99% level of confidence. Okay, the first thing we're going to do is find the standard error of the mean. It's your standard deviation here, 2.4 over the square root of n, which is 100. And that's going to be used in all 3 of these. Okay, so you're going to have 2.4 divided by the square root of 100, which is going to be 0.24. That's your standard error of the mean. Okay. This population mean right here, 24, is going to be used in every single one of them. You'll be going plus on the n on one side, and you'll be going minus on the other. But it'll be used in all 3 places to give you your interval. And the 90% level of confidence, we'll go back here. Look at the chart. The 90% is the 1.65. The 95% is the 1.96. And the 99% is 2.58. So that's what you are going to be multiplying by this 0.24. You will have and I use 645, we'll just go to 1.65 times the 0.24. And then this one was 1.96 times 0.24. And 2.58 times 0.24. This right here is 0.396. This right here is 0.4704. And this is 0.6192. So I'll be adding that to 24 and subtracting it from 24. And what I end up getting then is the interval from 23.604 up to 24.396. Okay. The next interval I get is from 23.5296 up to 24.4704. Now you can see this 23.6 and then it drops back to 23.5. The last one is 23.4. So each one of them is, this is dropping backwards and this is going forward. So it's including a little bit more area each time, which accounts for the 99% level, the 95% level, and the 90% level. So here's what I was saying. When you've got this and it's going between 23 and 24. When I started, I'm a little bit over halfway. I'm at 23.6 and I'm at 24.3. Okay? So that goes from here to here and covers this much space. Then I've got 23.5, which is back a little bit, and 24.5, which is up a little bit. So now you can see I cover more area. The last one, 23.3 and 24.6, you can see that covers the most area of all. So I start out with the 90% area, then the 95% area, and now I've got the 99% area. That's what happens the farther you cover. Okay, example 8.2. Suppose scores on exams and statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. A random sample of 36 scores is taken and gives a sample mean of 68. Find a confidence interval estimate for the population mean exam score, the mean score on all exams. Okay, we are looking for a 90% confidence interval. So when you go back to your chart here, that's that 1.65 or 1.645. I'm just rounding it off to the 1.65, which is fine. And it's going to be multiplied by the standard deviation of the mean. So we've got 3 points as your standard deviation, and we took 36 scores. So this is 3 divided by 6, or 1/2. So we've got this times that. Okay. And the 68 is your mean. We're going to add it to 68, and we're going to subtract it to find the left side of that interval. So 1.65 times 0.5. Get 0.825. So on this side, the right-hand side, it'll be 68 plus 0.825. And on the left-hand side, it'll be 68 minus 0.825. So that will give us, the adding is pretty easy, but the subtracting, 68 minus 0.825 gives me 67.175. So 67.175 is the left-hand boundary, and the right-hand boundary is 68.825. So there's your interval with the 90% confidence interval. And we'll look at the video 3.